Right now, 1 in every 200 men on Earth is believed to carry the DNA of a single man who lived 800 years ago. That man is Genghis Khan. Scientists published it, National Geographic ran it, textbooks included it. Nobody questioned it for over 2 decades. Then researchers opened 4 elite tombs in Kazakhstan. And what the DNA inside said changed everything. Temujin entered the world in 1162, born into the harsh Khinty Mountains. By 1206, he had forged unity among the Mongol tribes, taking the name Genghis Khan and setting in motion a campaign that would redraw the map of Eurasia. His armies surged from the Sea of Japan to the Danube, building an empire that eventually covered nearly 24 million square kilometers, the largest contiguous land empire in history. The toll was immense. Historians estimate the Mongol conquests and their aftermath claimed up to 40 million lives, erasing cities and scattering populations. Yet from this devastation, a new order emerged. Genghis Khan established a strict patrilineal system, dividing his empire among his sons, Joshi, Chagatai, Ogadai, and Tului. Through dozens of wives and concubines, he fathered a dynasty whose male line descendants ruled vast territories for generations. Over time, the number of direct male line descendants grew from hundreds to thousands, each with the right to expand their own line. When Genghis Khan died in 1227, his legacy was not just territorial, but biological. The scale of his conquests and the structure of his dynasty created conditions for a single paternal lineage to saturate populations across Asia. The story of the Mongol Empire is not only one of military might, but of demographic transformation. The reach of Genghis Khan's bloodline would echo through centuries, shaping the genetic landscape of millions and setting the stage for questions that scientists are still trying to answer today. In 2003, geneticist Tatiana Zerjal and her team set out to answer a question that had hovered over the legacy of the Mongol Empire. Could the impact of Genghis Khan's dynasty be traced directly through DNA? Their approach was bold and methodical. They collected Y chromosome samples from more than 2,000 men across 16 populations, stretching from the Mongolian steppe through Central Asia and into the heartlands once ruled by the Khans. The Y chromosome, passed from father to son, acts as a genetic signature for paternal lines, unchanged except for rare mutations, making it a powerful tool for tracking ancestry across centuries. What Zerjal's team found was extraordinary. Within these samples, a single Y chromosome haplogroup labeled C3 star, later known as the star cluster, stood out. It appeared in about 8% of men across the region, and in some Mongolian groups it reached even higher frequencies. Statistical analysis pointed to a most recent common ancestor living about 800 years ago, a date that fell squarely within the era of Genghis Khan's rule. The pattern suggested a rapid, explosive spread, consistent with the social dominance of a powerful male lineage. But there was a catch. Zerjal's study never claimed to have Genghis Khan's own DNA. The inference rested on timing, geography, and the known reproductive success of the Mongol elite. The original paper acknowledged this gap, noting that without a verified sample from the Khan or his immediate sons, the link could only be considered plausible, not proven. Still, the story took on a life of its own. Headlines declared that 1 in 200 men alive today, about 16 million, were direct descendants of Genghis Khan. The star cluster became shorthand for his genetic legacy, appearing in textbooks and documentaries worldwide. Yet beneath the surface, the foundation was always an assumption. The leap from a widespread Y chromosome pattern to the legacy of a single historical figure blurred the line between inference and proof. The question lingered. What if the story was more complicated than anyone imagined? In the heart of Kazakhstan's Ulytau plateau, a team of archaeologists and geneticists assembled under the spring sun of 2023. Their permits, secured after years of negotiations with the Ministry of Culture and Sports, allowed them to open ground that had lain undisturbed for centuries. The site was 4 stone mausoleums arranged on a limestone rise, their presence hinted at in medieval chronicles and Kazakh oral tradition. Over 30 specialists from the United States, Japan, and Kazakhstan converged on the site, each bringing a discipline like stratigraphy, osteology, conservation, and radiocarbon science to the task of uncovering the past without erasing its context. The excavation lead, a veteran of steppe archaeology, directed the team's vertical profile approach. Using Total Station GPS, they mapped the mortuary complex, then opened test pits to trace the outlines of each chamber. The architecture spoke of power, with deep-set burial shafts lined with timber, capped with heavy stone, ringed by ditches and caches of horse bones. Inside, the grave goods left no doubt about the status of those interred. Gold inlaid sword hilts, silk textiles, ornate belts, and ceremonial daggers rested alongside the skeletal remains. Each item was cataloged, photographed, and logged for conservation. Radiocarbon analysis of charcoal and bone placed the burials between 1240 and 1285 CE, aligning with the period when the Golden Horde reigned over these steppes. The stratigraphic sequence showed a single main construction phase, with later secondary burials in two chambers. While medieval sources describe a grand mausoleum for Joki, Genghis Khan's eldest son, the tombs lacked inscriptions or royal crests. Still, the combination of elite architecture and grave inventory pointed unmistakably to the upper echelons of Mongol society. What remained uncertain was what secrets the bones themselves might still hold. In the controlled environment of the laboratory, the remains from the Ulytau tombs underwent a battery of genetic tests designed to capture even the most degraded traces of ancient DNA. The team focused on the Y chromosome, a strand passed exclusively from father to son, serving as a living record of paternal ancestry. Targeted sequencing revealed a result that startled the geneticists. All three elite male individuals carried the broad C2M217 haplogroup long associated with Mongol imperial lines. But the detail lay in the subbranch. Instead of the widely distributed star cluster linked to Genghis Khan in the 2003 study, these individuals belong to an obscure offshoot, C2A1B1A1B 5480. In a modern survey of 15,000 Central Asian men, this rare variant appeared in barely 0.02%, just 3 individuals out of thousands. The implications were immediate and unsettling. For 2 decades, the narrative of the Genghis Khan gene had rested on the assumption that the most common C3 star lineage, now called C2, had spread from the Great Khan himself. Yet the DNA from those closest to his ruling house pointed to a branch so rare that it had nearly vanished from the modern gene pool. John Hawkes, a leading population geneticist and co-author of the 2026 study, put it bluntly. The C3 star lineage we see in the Ulatau elite is not the star cluster that constitutes the 1 in 200 claim. It is a peripheral branch that barely shows up in modern surveys. This finding forced the scientific community to confront an uncomfortable truth. The most famous genetic attribution in world history, repeated in textbooks and documentaries, had never been anchored to a confirmed sample from Genghis Khan or his sons. The Ulytau evidence did not erase the possibility of a vast Genghisid legacy, but it shattered the illusion of certainty. The story was no longer about a single dominant lineage sweeping across Asia. It had become a question of which branch, if any, truly bore the mark of the Great Khan. 3 possible explanations now stand at the center of the debate. First, the widespread C3 star cluster could trace to another of Genghis Khan's sons, Ogadai, Chagatai, or Tolui, whose descendants also commanded vast territories and whose lines remain deeply woven into the history of the empire. Second, the lineage might predate the Mongol conquest entirely, representing an older steppe ancestor whose Y chromosome was later amplified by the rise of the Mongol elite. Third, the only way to settle the question is with a verified DNA sample from Genghis Khan himself, a sample that has never been found. Each scenario points to a different origin for the so-called Genghis Khan gene, and each leaves the mystery unresolved. Rashid al-Din, writing in the early 1300s, described a burial so secret that every witness was put to death, and hundreds of horses trampled the ground, erasing all trace of Genghis Khan's grave. The site's exact location vanished from memory, protected by ritual and fear. Today, that legacy of secrecy shapes not just legend, but law. Mongolia and China strictly control access to suspected royal tombs, requiring state permits and community approval before any excavation. Heritage statutes mandate that remains be reburied according to tradition, and DNA analysis is tightly regulated. Even with advanced technology, the search for Genghis Khan's tomb faces ethical barriers as formidable as any physical obstacle. The question of his true genetic signature remains locked beneath layers of history, ritual, and national pride. Y chromosome studies rely on assumptions that can easily shift the story. The choice of mutation rate for short tandem repeats changes the estimated age of a lineage by centuries. Markers that look identical may have arisen independently, a problem called STR homoplasy. Only strict lab protocols like using the Petrus bone and double indexing guard against contamination. Without a verified ancient sample, every genetic inference carries a margin of uncertainty. Science once declared 16 million men carry Genghis Khan's Y chromosome, but no confirmed DNA ever tied that legacy to Temujin himself. Today, the mystery grows sharper, proof that even the most accepted stories can hinge on missing evidence. History's greatest conquest may be the truth we still can't find.